This is day 8 of Unit 5. So we started today with this warm-up. So pause the video, try the warm-up, and then play to check your answers. So there's the warm-up. So I take each of the roots and turn those into factors. So 0 becomes x or x minus 0. 2 becomes x minus 2. 1 plus I becomes x minus the quantity 1 plus I. And then the other root, which I wasn't given, but I know, is the conjugate of 1 plus I, which is 1 minus I. So x minus that. So distributing the negatives, multiplying, and then multiplying again. There's my work for that. Take a moment and check your answer for the equation. Okay. So today we solved systems of equations that are nonlinear, or at least one of the equations is nonlinear. We did that both graphically and algebraically. So we started by doing this one here algebraically. So you want to put that in your notes. So in order to solve that, I'm going to substitute x minus 2 in for y, which says I'm going to subtract 2 and then add 2. So when I do that, I'm getting just an x, and that squared equals 4. So in order to solve this for x, I'm going to have to square the x plus 2, which gives me x squared plus 4x plus 4, plus the x squared, and that equals 4. So I'm going to combine like terms, 2x squared plus 4x. I'm going to subtract the 4 from the 4, so that gives me just equals 0. So I know how to solve that. It looks like it factors. So 2x factors out. I'm left with x plus 2 equals 0. So I have x equals 0, and I have x equals negative 2. So those are the x values. Now I'm going to substitute those back in, of course, to the easier equation, the top one, and figure out the y values. So putting 0 in, 0 minus 2 is negative 2. So 0, negative 2. And putting in negative 2 minus 2 is negative 4. So negative 2, negative 4. So those are my two solutions that I get algebraically. Hopefully I'll get the same when I solve graphically. So y equals x minus 2, I'm going to plot that. Slope is 1. So I'm going to go ahead and draw my line. Next, I'm going to graph this. We talked about the graph of these yesterday. That's a circle. So hopefully you remember that the vertex, or I'm sorry, the center of the circle would be negative 2, negative 2, and the radius would be 2. Look back on your notes from yesterday if you're not sure how I came up with negative 2 for the center and for 2 and 2 for the radius. So I'm going to negative 2, and I'm using that point as my center, so I'm going right 2, putting a point, up 2, left 2, and down 2. And I have those 4 points. And I'm going to do my very best to draw a circle. Oops, got a little bit off there on that one. So then I'm going to label those points of intersection, 0, negative 2, and negative 2, negative 4, which are the points that I came up with algebraically. Next, so copy those two equations. Same thing, we're going to solve algebraically and graphically. So I can see these are both solved for y, so I'm going to set them equal to each other. I can see that I have a cubic, so I need to get that set equal to 0. So subtracting x and adding 2. I can see that I can factor that. So that's times negative 1. So GCF here is x minus 2, x squared minus 1, which factors further. So we're getting x is positive 2 and plus or minus 1. So I'm going to substitute those back in. Looks like the second equation is more simple. So I'm going to put 2 in. I'm going to put 1 in. And I'm going to put negative 1 in. So we're getting negative 1, negative 3. So now I'm going to graph those. Again, I have the same line I had in the last problem. And this time I have a cubic. Well, I don't know what that cubic looks like because it's in standard form. So I have to solve for the zeros or find the x-intercepts. So I'm going to set y equal to 0 in that top equation. And I'm going to factor it. So that I know that x equals 0 and x equals 2 are the roots. So I'm going to go ahead and plot those. And looking at the equation, I can see because x is squared, I know that x equals 0 is a double, and x equals 2 is a single. I'm also going to look at the equation to determine the degree and the end behavior. So I see it's cubic, so degree 3, and it's positive. So positive and odd, remember, it means down, up. Okay, so I'm going to make it have a down, up, end behavior. I'm also going to use these points to help me. So I'm going to plot them, negative 1, negative 3. It's right there. 1, negative 1 is right there, and 2, 0. So I know the end behavior on the left side is down, so I'm going to make it go down through that point that I know is a point of intersection. I know it's coming up here to 0, 0, and we said it's a double, so we know it's going to bounce. So I'm going to make it hit that point and bounce. I know this is another point of intersection, so I'm going to make it go through that. And then I know that it's going to go through at 2, 0 because it's a single root. And I know that it's going to end pointing up. So I'm going to make it do that, go through at 2, 0 and end pointing up. So we have points of intersection are, whoops, I don't know why I wrote that there. Points of intersection are right here, negative 1, negative 3, positive 2, 0, and 1, negative 1. Next, this one's in your packet on page 16. It's problem number 2. So we're going to solve this one first algebraically. Now, we could do the obvious choice and substitute in for y. However, if we do that, we're going to have x squared plus x squared minus 13 in for y squared equals 25. That's going to become a little bit of a mess to handle. We could square the binomial, but it's an x squared that we'd have to square, and that gets a little bit messy. So I would suggest trying to come up with an easier solution. And if you look at both equations, you should be noticing they have an x squared in common. So if they have an x squared in common, what we could do is solve this equation for x squared, the top equation. So x squared is equal to y plus 13. And then I could substitute in to this equation for x squared. So that would probably be a little bit easier. So that's what we're going to do. We're going to replace x squared with y plus 13 in the second equation. So I'm going to rewrite that and get it set equal to 0. So if I subtract 25 from 13, I get negative 12. And if I factor, it looks like plus 4 and minus 3. which gives us y equals -4 and y equals +3. So those are my y values. I'm going to substitute in, looks like the top equation would be a little bit easier maybe. So -4 goes in for y. I'm going to add 13 because I can use square roots here. So if I add 13, I'm getting 9 equals x squared. Square root of each side, absolute value of x, hopefully you remember that, is 3. So x is equal to ±3. So then solving the opposite, actually let me write the coordinates first. So 3 goes with -4, -3 goes with -4, and then I'm going to go ahead and put 3 in for y into the first equation. So 3 equals x squared minus 13. Adding 13, x squared equals 16. Square root of each side, absolute value of x equals 4. So x is equal to ±4. So writing that as coordinate points 4 with 3 and -4, -4 with 3. So I'm going to go ahead and graph and hopefully find 4 points of intersection. So the first graph, I'll skip for the moment. I'm going to do the bottom one, which is a circle. Again, you should be able to look at that and know the center is 0, 0, and the radius is 5. So I'm going to 0, 0, and I'm going 5 to the right, 5 to the left, 5 down, and 5 up. And I'm graphing that circle. Okay. Next, I'm going to look at the parabola, which I can see is shifted down 13. Now, I could get the x-intercepts, but I'm just going to plot these points and hopefully see that they're on the circle. And then I'll just draw the parabola through the vertex and those 4 points. So 4, 3 is right here. -4, 3 is right there. 3, -4 is right there. And -3, -4 is right there. So now I have those 4 points and my vertex, and I can easily draw my parabola. So intersection points 3, -4, and -3, -4, 4, 3, and -4, 3. And those are my solutions, both graphically and algebraically. So that was it for notes today. Homework is to finish up page 16 and then work on page 17 for tomorrow.